Hello everyone, myself Manas Upadhyay. I am currently pursuing Construction Engineering Management from the CEPT University. I am in currently semester 3. So during this studio we have to work on different kind of project and our group has selected the corporate tower. For different analysis of our project, I will take you on a further slides of our project. So now moving to the project brief, our corporate tower consisting of two buildings which is EH1 and EH2. In that we having three basement, ground floor and the 15th floor of our project. During this study we have done for EH1 tower only. So our project is a greenfield project and a commercial project. The project site area which is 10 acres and the built up area is 15,778 square meter. The type of contract is item rent contract and the cost of our project is 450 crore. For the scope of our studio, we have taken the basement 3, 1 and ground floor. The start of project is on 3rd September 2022 and the completion date is January 2025. This is the location of our project. During this study, we have prepared for the architecture, structure and MEPF model for up to 350 LOD. For during this, we have taken the basement 1, 3, ground floor and 4th floor. Up to 10th November 2024, the current status of our project is we are on having 13th floor pour 2, 14th floor pour 1. The RCC work is completed up to that date. So I am the beam coordinator. I have identified all the clashes of architecture, structure and MEP model and checking the status of all models and creating the RFI. And also I am a firefighting consultant, so I have prepared LOD 300 model for firefighting elements. So now moving to the EIR component and BIM execution plan. So EIR is a basically requirement from the employer, the client. So in this, the client will be required the architecture, structure and MEPF model. For further changes in design, so we have to create a 3D model for LOD 300 and LOD 350. The major problem we identified that we don't have the site layout plan, so we develop an optimized site layout model to optimize the circular of vehicle and labor movements. Us we are not having a beam approach and during this our project, so we have avoiding of drawing disparity and quantity takeoff. During this beam we can identify directly take the quantity takeoff from the rabbits, which will help for our project. And these are the beam execution component overview like scope of work studio, key project contract, project delivery schedule, technological infrastructure, risk analysis and project delivery. So now moving to the collaboration strategy. The first is a big room where all the stakeholders will be aligned and we have to work on our project and identify the scope of our project and the project life cycle. The second is Google Meet. We can done through the Google Meet also. We discuss about the clashes and everything. Third is Google Drive where Beam coordinator will be share the all the template. The ISO planner will be get the all the flow of Beam process. Google Keep Notes, Microsoft OneDrive. So I am a beam coordinator. These are my four consultant: architecture, structure, MEPF, and contractor. So after working on the project, we have to done the minutes of meeting where we will talk about the agenda of our status of our project like architecture, structure, MEPF, and plumbing. We can see this the status of our project in basement 3 20% is completed, in LOD 300 40% is completed. This is along with the status of our project. Yeah, so I am a beam coordinator. Now I will take you to the beam execution process where beam coordinator will be check all the quality control and beam use analysis. He will check the visual check like grids, level, project baseline and units, and also the standard checks like folder management, naming conversion, material specification and relevant template. Also along with this model quality check like LOD as per MEA, model accuracy, no overlapping elements, avoid locking walls to floors and ceiling, Revit cartling alignment, clear height constraints. So this is the measure we have prepared for like beam use life cycle. These are the primary and secondary beam use which is not in our project, and this is the high scope beam use and in scope beam use which is in our project. So these are the four stages like planning, design, construction and operate. So existing condition modeling will start from the planning stage and will go to the operation stage. Like phase planning will be start in planning stage and it will be completed in planning stage. The design review will be done start from the planning stage and it will complete to the design stage. 3D coordination will be start from the construction stage to go to the design stage. Not like that, but these are will work in these two stages. Like record model maintenance, these are the 10D which is not in our scope. So we have taken this site utilization planning. where we'll do in the construction stage, where the major responsible of our project will be the contractor. The value of our project will be so high as a 3D design software will be used the Revit. We have done the competencies for ability to make appropriate construction decision using a 3D model. The project phase, this will work in project phase. So now moving to the traditional versus ICP approach. In our project, we approach the traditional approach, and during the studio, we have differentiated with ICP approach. So it start with the strategic process and go with the handover process, and these are the all the stakeholders which will come in our project. It start with the client brief. After appointment of the project architecture consultant, they will go to the conceptual stage where all the architecture and structure model will become. And in schematic design, all the designer like MEPF designer will be come in the role. We see in the red line there are so much of loop we have identified in our project. We create the delay of our project. We seen in detailed design phases also that up to design is still not completed, and we'll move to the execution phase where still the RFI is raised by the contractor because the design is not up to the mark. Then this cause our project delay, and that this is the handover process. So this is the challenges in traditional approach. We identified that multiple loops in design, stakeholder coordination which is not up to the mark, and the rework and revision, delay in decision making, and cost resources insufficiency. We face significant difficulties due to the absence of beam, resulting in frequent rework. The client struggle to visualize critical elements as drawing were in 2D. Excessive design revision during execution added unnecessary complexity. The coordination gap between consultant caused repeated iteration, increased project cost and inefficiency. So this is the ICP approach we have prepared for this or our project, that this can be used for our project, which can be cause, which can be help to our project. So it start with the strategic process where we appoint the beam contractor will help for the project, and start with the conceptual stage where all the LOD 300 model will be completed in the schematic design phase and detailed design phase. We have to done the clash detection process also, which help for our project to identify the clashes. Up to the when the clashes will be not identified or not clear, the execution will be not start. So all this process will be completed up to the detailed design phase. Then the execution will be start where the site layout model will be prepared by the site contractor, will take the quantity take off and go for the 4D simulation and 5D simulation. In 4D simulation we can visualize all the models in sequence, what are the delays we have identified which we have worked on the Navis work, and in 5D we can compare with the cost as per the schedule. And these are the benefits which we identify for the our ICP approach, like streamline workflow, early clash detection, reduce rework, improve collaboration and decision making. The ICP approach integrated beam coordination early in the project. LOD 300 model are developed and integrated earlier and upgraded to LOD 400 by the detailed design phase. Continuation among stakeholders, faster, better alignment and decision making throughout the project. Yeah, so moving to the main important part, like 4D simulation, in which we have done 6 week milestone schedule. It start with the 10th September and completed to the 10th November. The floors which we have taken 12, 13 and 14 floor, up to the project scope is LOD 300 and 350 model for structure model. Basically we have prepared the milestone schedule for this, and we have compared the plan versus actual model, what is the plan we have prepared and what actually going on the project side. So we have compare and prepare the video also for that, and we will move to the further, we will discuss about how this 4D simulation will work. Yeah, so this is a plan versus actual, which we face the major problem that delay element and duration, which we show in the below. So the concrete strike has been begun, which on 17th October, which caused the 70 days delays, which we have found the major delay in the actual. In plant, we have seen that the pour 2 of 13th floor should be completed up to 27 September. Because of concrete strike, the project is delay of 70 days. In we identified which caused the major delay of our project, and one other cause we've identified in shuttering because of lack of labors. So this is the plan versus actual difference. This is the plan for the simulation which we have made, and this is the actual what's going on the sites. So now moving to the use case. The use case is for what difficulty or uncertainty which we have identified on our project. This is not the problem is currently now, but it is on the early stage because in our project they are not using beam. So we have given the beam and we have prepared the solving resolution for that. So this is the beam use case where conventional formwork used, peri formwork used, FF pharma formwork used, column case, and ecospedy formwork. This is in 4.2. So from this we have created the 3D model of this use case and created how the workflow will be gone in the sequence, which help to the client also to identify the problem or the changes. So basically this 4D simulation help us to visualize sequence of execution with more accuracy and how different formwork has to be sequenced in a complex area. So this is a QR code where you can see the video of our use case and the 4D simulation of plan versus actual, which will be clear how this workflow will be go and throughout the project. Yeah, now moving to the conclusion. EIR beam execution plans. We have created the model structure beam standard. This plan give LOD 300 350 model for architecture structure and MEPF model. We have also done Google Drive a collaborative platform will help for the transparency and coordination among stakeholders. In traditional versus ICP approach, we have seen that there are many miscommunication during the fragmented workflow and lack of visualization tool, which beam ensure early coordination, reduce redesign and provide a seamless execution phase, saving time and resource while improving project outcomes. In 4D simulation, we identified that the integration of 4D simulation providing a clear visualization representation of the construction sequence by linking schedules with the 3D model, stakeholder could foresee the potential bottlenecks and manage delay more efficiently. The 4D simulation enables stakeholders to identify and address delay, making it invaluable for timeline management. Simulation allow for adjustment in advance, ensuring effective resource allocation to prevent disruption. So this is our complete portfolio in which we have done the EIR and beam execution, traditional versus ICP approach, and 4D simulation, which help this beam approach to the execution on site, which help for the further delay to identify what can be delay in our project, which help to the client what can changes we can modify to our project, also help for the quantity takeoff, where we can take the directly quantity of this curved beam, ground beams, circular shear walls, which we find the major difficulties in the 2D. This is the beam approach. Thank you.